Alright, so we did Abies, pinsapo, Glauca. It is our class tree, as you might know. It has whorled leaves on branches. Has pale green / purple cone. Requires a full sun. Has a spread of 4 to 8 meters. Can get to be 12 plus meters tall. 20 to 50 years to mature full height. It's pretty slow growing. It likes rich, acidic, well-drained soils.
USDA zones 6A to 9B, rigid layered branches, short needles. We're running out of things to say.
Has small violet cones in the spring. Narrow, pyramidal, upright form. Slow growth.
The needles have white banding all around them, and new branchlets are completely surrounded by the needles.
Can you find a picture of the cones there, Eric?
I think this one is
so that we can see. No, that's not it.
That picture. Or like the one below it. Right
No. There it is, over there. There, up, whoa, right there.
This?
Yeah. Just shut the lights up here. Right. The big thing with Abies cones. What did I say about Abies cones?
Upright?
They're held upright above the foliage, and they unfurl. So you can't actually collect an Abies cone, because if you do and put it in your pocket, it will come undone in the heat. So that you're usually left with a stalk. But that said, they are ornamentally significant. pH. What's an acidic pH?
1 to 6.9.
Below 7, yeah. So anything below 7. So if a plant, if it's listed that it says that it needs or requires an acidic pH or prefers acidic pH, what's the difference, right? We have neutral soils here, probably 7.2, 7.4, right? So our soils are alkaline, yet we're growing a lot of acid-loving plants, and the last two that these folks described are acid lovers. Right? So they actually prefer it, but they will do quite well in a fairly close range. It's when it gets to be above, say, 7.5, 7.6 that you can run into problems, right? So pH is a kind of a literal.
What happens?
You get, if you remember from your soils class with Jack showed you a square box. This is probably the most important thing in soil science.
I can bring that up right now.
Can you bring it up? That is probably the most important thing that you've learned in soil.
Oh, yeah.
I don't know what it's called.
Nutrients?
Yeah. So pH.
Oh yeah.
So pH, nutrient availability. There it is, right there. The colored ones, right there. Yeah.
Oh,
So
okay.
that is probably the most important thing to understand in soil science, and it's pretty simple when you look at the pH and you look at the relative nutrient availability. And for most plants, it's an acid problem. The soil is not acidic enough, and the nutrient that shows up most is iron. If you look at iron up there, which is about halfway down on the page, look how it dramatically changes at mid-range pH, right? So things like Acer rubrum and hollies and conifers and such will start to show symptoms. It's pretty easy. I think you saw that at the start of the term. You saw interveinal chlorosis. You get called out onto a job site as a consult, and you can say, that's interveinal chlorosis, and that's caused by pH, and here's a simple solution. Acidify the soil, iron chelate, sulfur, bang, problem solved. You're worth your $150.
Yeah.
Okay, very good. Next.